is no credit. So make sure that you know what I'm talking about with labeling your graph. Use your mean, put your mean in the middle, use the concept of standard deviations, and label and sketch your graph. So if we're looking for an x value to be less than 170, the probability is area under your curve. So if we're looking for the probability to be less than 170, here's where 170 falls. So we're looking for this probability. Okay, so again, you can see that it's less than 50%. That's a good eyeball thing to look at. Okay, if it's greater than 182, then I'm shading to the right. And that looks like it's less than 50%. So when I look up my answer and I see that it's more than 50%, I'm going to subtract it from 1. Okay, also remember, you can look up the opposite. Instead of looking up the 0.4, you can look up the negative 0.4 because it's the same exact area to the left of the middle. Yes.
Do we ever do like less than or equal to?
Well, we don't really do the less than or equal to part. We just leave it all greater than, less than. Yeah.
If we only put the like 0.4, but we don't put the 0.646, did you have points?
Well, that's your z-score. This is your probability. This is your area under the curve. So if it's asking for the probability, you have to give me this answer.
So we give that what?
Yeah. We look up 0.4, and whatever 0.4 is, you're going to have to subtract it from 1 because it's the area to the left. And you're going to end up with 0.3446. Now you can also look up a z-score of negative 0.4 to get that area. Yes.
How do you know when you do the 1 minus?
Okay, so that's where your sketch helps you. Your area on the curve is always to the left. So if you want area to the right, you have to subtract it from 1. But here's what helps me. I look up this guy here. I say 182 falls over here. Here's my mean of 174. 182 falls here. I want my area to the right. So, Marissa, is this area less than 50% or more than 50%? Less than. Now, when I look up a z-score of 0.4 on my table, it's going to give me an area to the left. Anybody look up 0.4? What does 0.4 say? 6551. Thank you. Now, isn't that more than 50%? So that's why your sketch helps. Because this can't be more than 50%. So I say, oh, I must have to subtract this from 1. Right? So if you kind of use your sketch as, I need it to be more than 50%, I need it to be less than 50%, that really helps you when you look in your table. And don't forget, you can look up the negative 0.4, because this area over here is the same exact as this area over here. So use the concept of symmetry, and then you don't have to subtract from 1 at all. Just look it up the opposite way. But I think if you, that's why I'm a kind of a fussy pants about the sketching right now, because I think it helps you put everything in perspective. What did I expect? Did I expect more than 50%, less than 50%? You know, it kind of gives you a good feel. And if you remember your empirical rule, your plus or minus 1 is 68%, your plus or minus 2 is 95, your plus or minus 3 is close to 199.7. Even that plus or minus 1 kind of helps you out. So when we look for it in between, such as this guy, look where 66 is. This is where my 66 is, right over here. And my right here is my 66.5, so my 66 is real close. My 72, real close to that. Isn't that between plus and minus 1, approximately? So shouldn't I expect 68% around there? And when I do this, look what I get, 69%. So am I in the ballpark? Yeah. See, if you guesstimate your answers, it's really going to help you when you look them up. Remember, the calculator is a little bit more exact because here's our problem. We have z-scores to round. We rounded our z-scores. So when you round your z-scores, your area is rounded as well. But your calculator doesn't do that rounding before it subtracts your areas. So your calculator answer may be just a little bit different. So when you take a test or something, you just tell me, calculator. And I'll know you give me your calculator steps and you bypass all of this. This whole thing right here, you bypass this by using your calculator. And absolutely use your formulas. So we had one where we looked for it to be less than 66. And again, this was 66.5. It's real close to that. However, I want my area to be less than 50%. When I look it up, it is less than 50%. I am in the negatives over there. I'm close to the -1, so everything makes sense according to my sketch. Right? The sketches I find really help put it into perspective for you. The in-between, remember when you do an in-between, find your z-scores. Now you found this one already. Did you have to redo it? No. And this one you're already finding for this one, so do you have to redo your z-scores? No. Because you already looked them up and you found them. When they do something like with a 1, 2, 3 or ABC, it's kind of nice when they use the same. And in between, remember you're subtracting your areas, not your z-scores. And then a greater than, if I'm greater than 72, it's real close to that line. Real close to this part. I expect it to be less than 50%. Way less than 50%. Because plus or minus 1 is 68, so half of that is 34. So I only expect 50 minus 34. I expect it to be about 17%. And look what my answer is, 18%. So kind of like put it in perspective. Make sure you understand why you're doing this. These are probabilities. Your area under the curve relates to your probability. Everybody good so far? Stop me if you have any questions. Okay, again, here's another one, ACTs. ACTs, again, are normally distributed. And right now they have to tell us it's normally distributed, or we can't assume to make a normal curve. Pull out your mean, pull out your standard deviation, make your chart. Find a student who is less than 16, in between 19 and 24, and greater than 26. This time they didn't give you anything to reuse, so you had to do them all 3 again. Good? I'm assuming it's good if I don't hear anything otherwise. Yeah? Alright. So once you get the hang of it, it's kind of like pretty much the same thing. I just wanted you, like repetition is good. Repetition is good because you become more comfortable with it. So when you find something that's a little strange, and you say, could that really be? You're pretty much more confident that you did it right. Okay, the amount of time an athlete uses a stair climber, so we're looking at time. Time is your x value. So it's normally distributed. We make a normal curve with the mean of 20 and a standard deviation of 5 minutes. Find the probability that I randomly select a stair climber and I ask him if he did less than 17 minutes. So the probability that I picked one that did less than 17 minutes is about 27%. Okay? Between 20 and 28 and above 30. Again, use your graph. Above 30 has to be less than 50%. So when I look it up, and this is a large number, I say that can't possibly be because look where I am in this little tiny area. I have to subtract from 1. Everybody comfortable with the calculator in case you want to use the calculator? Okay? Just remember to put your mean and your standard deviation in when you use your x values. Okay, this is for number 13. Okay, so they wanted to know an in-between, and they gave us a graph. I don't think you can see my coloring in here too much. There's my blue. I want the in-between pieces. There's the blue, and there's the what's left in between. Just use your mean. Pull it right off your score. They didn't align this to your standard deviations. The book likes to put your x values on the bottom. I don't. Remember to find your z-scores, subtract your areas, not your z-scores. So it's the same thing, we just had to pull it off of the graph. Okay. Here's my little line. what percentage is less than 600? And, okay, so what percentage is less than 600? We use the mean, the standard deviation, we find our z-score. Again, did this go to this chart? It went to this chart. So less than 600, we're above the mean, so our standard deviation has to be positive. We find to the left, we find our area, and then we use this for forecasting, for predictions. We say out of 1,000 randomly selected SAT writing scores, out of those 1,000, how many would you expect to be greater than 500? So 500 is a little bit to the right of the mean. We calculate the z-score. We calculate the probability. There's a 46% chance of being greater than 500. We multiply this by the 1,000 to find out how many z-scores there are, how many papers above 500 there are. Okay? Good? Yes. I know it's a little tedious, but you know what? You get the hang of it a little bit faster. I think this is your last one, right? Okay. Again, they took this off of a graph. You're going to do the same thing. Find your z-score. What percent have less than 225? So, again, you have to set that up separate because they didn't use the same numbers. Find out the percentage less than 225. Now, 225, here's your mean. 225 is above your mean, so to the left is a big chunk of area. Come on. Yes. The library pass? Sure. Okay, thank you. Your library pass?
Yeah, they called for it the last year, but I didn't have a computer.
Okay, so you have to bring it to the lower lobby. I'm going to pass right by you. I'm going to bring it in. I'll pass by you. Rather than have you call in here. All right. Are you passing by there next period?
Yeah.
So you are passing by there? All right, I'll give you. I have one more period after this. Otherwise, I'll call you again. Yeah, we'll leave it on your table this time. Leave it on your desk. Okay, and your last one, again, out of 250 randomly selected men in this age group, how many would you expect to have a cholesterol level greater than 260? Find your area first, and then calculate off your percentages. Don't forget to subtract it from 1 because you're greater than.